Can you guys see the screen?
Yeah.
Okay. So today I'm going to explain about first links. So first links and then pointers. Oh, my hands. Pointers. Okay, first. Okay, let's first create some with using data type int. We will create some variable, for example num, and let's give some value, for example maybe 10, and we want to create another variable, for example new num, and we want to use new num and storage inside the new num our num here. So in this case, if we'll run our code, wait, I have to print out first. Okay, here in our case variable num storage 10, right? So we are using 4 bytes of our computer RAM, and variable num using 4 bytes, and also new num also use saves inside new num variable, and also use 4 bytes, and totally together num and new num we use 8 bytes. So but if you look here, we want to show like 10, right? And in this case we can use if you write this ampersand symbol here, it's gonna be link. So we are saying new num, it's says address of num, so it's not gonna use 4 bytes. Okay, let's print out our num, and let's print out first address of our num value, and also here our num value. Okay, and also let's print out our new num also address. And let's run first code. And if you look at the our output, this address and this address are the same, right? And also value 1010 also the same. So what it means? It means our new num is saving address of num to let's do like this. Let's create okay, old num, and we want to also storage inside of old num our num. So we are saying also here num and num, right? And let's also print out our old num, but old num is not linked, right? Here. So address of old num and just value of old num. So if you print out this one, it's, if you look here, same address, this one and this one same address, right? But last one is different address, but value is 10. Because old num is not saving address of num, it's just saving value of num, 10, right? And okay, let's change our link new num to not 10, let's change to, for example, 128. And if we'll print out this, you can see these first two is changed to 128, right? And last one, old number, is still 10. So it means our new number saves address. Okay, new number save address of number, which changes our number value 10 to 128. But old number is not saving our number address, so it's not changing value of 10, so it's still 10 in number variable. Okay, and так. Okay, and let's go to pointers. And pointers and links, it's technically similar things, but pointers is more convenient to use in different, for example, arrays. So let's do same thing in pointers. Let's create some variable and give here 20. And let's create some pointers. Value. And to create link, we use this ampersand symbol, right? To create pointer, we have to use this star symbol. And difference between links and pointers, we can create just in pointers we can create empty pointer, and if we'll run, it's not gonna give any, it's not giving error, right? If we'll create just empty link and run, it's showing here error int new num. So in links we have to every time we have to save address of some value. And okay, to our pointers, let's give our value and okay, let's also print out this. Okay, first let's check our address of value and also value of our value variable. And to check our one thing, if you print out in links after writing like ampersand and new num and equal to num, right? It's working. But in pointers we have to write here also ampersand like this, and if you run, it's not giving error, right? If we forget to write ampersand also here, it's gonna give like this error. So it's technically points to address or value also is similar to links. And okay, let's print out also our pointer. Let's see, like this, and if we'll print out right here. Okay, let's look here. So here we can see address of value 20, address of value and address of variable, sorry, and value 20, and also we can see address of PTR val, which pointer, and value of pointer. And same thing, let's do with not pointer thing. Let's say not val, and save here our val, and also let's print out our not val. If we'll print out, if we'll see here, address here is different. Rather, if you'll see to this one, right? And if we'll do also, if we'll try to change our pointer, let's change our PTR wall to 200, 2000, like this number. Let's say like this. And but if you look here in links, we don't have to write our ampersand here, right? But in pointer, we have to write our symbol here, and then it's gonna work without error. So if you look here, these two numbers address are the same, and also values they changed to new one, right? And but this not value, which is not pointer, it's still 20. And also difference between links, we can remove or just make empty pointer. Let's say we finished using our PTR wall pointer, so we want to just delete or just clean our PTR value. So we'll write like this, PTR wall equal to null PTR wall. And here two numbers, and if you run it, okay, it became only one, right? So come on, I think I did something wrong here. let's check our PDF. If you look our PDF, so we did everything here, and for example here I explained this one, so it gives address and value, the same things, and so here it says we cannot use plus plus, we have to use these two, like pi pointer plus 1 or plus equal 1, and also we cannot use different type of data for our variable and pointer. So it says we're using integer type of data for I, and trying to use double data type of for PD pointer. So it says it's gonna give error, and also here it's saying we didn't clean our pointer. And if you look our 16 page, to clean our pointer we have to use null. Okay, I wanted to show one example. This program, it's okay, let's explain first this part. I just explained links and pointers is useful for not using a lot of amount of RAM in our computer RAM. So but in our in variables we're not using that much byte. So actually in array we use, if you look here 1 2 3 4 5, and every number use 4 bytes, and only this line of code uses 20 bytes in our RAM. And so we create array here, and inside the array 5 7 3 minus 2 and 5, and we're trying to find a minimum number inside of our array. So here we're using pointer to point our array, and here is trying to figure out our length, and here we create we're trying to find here minimum number inside of our array. And but if you look here, array here pointer array only points of first symbol or first number of our array, which is 5, and we trying to say here our minimum number is first number of our array. But if you look here, minimum number is not 5, which is like -2 here, but we're fixing with loop here, and in if case we saying if minimum number. Also one thing here, array, if you write just like this always will show our first array number, and we're trying to plus I, and which is going going to next number, which is 7, and next number 3 minus 2, and lastly we're saying minimum number. It's our array plus pointer. So if we'll run this code, it's not running. Okay.
I think it's set for
It's
the
running
number
with this
one.
code.
Yeah, remove the ship.
Okay, let's remove this.
Is it good?
What is the
Okay.
problem?
They should be like semicolons, like error expected before.
Ah, wait. Okay. Ah, this one. And okay.
What about the minimal array factor?
Where is it?
At the last
Ah, yeah. Okay. Okay, let's run again.
So between semicolons.
Maybe
Maybe for
inside for the semicolon it should be everything.
also
No
in the
comma.
in the sorting.
No comma, but everything is in.
Like this.
Yeah.
Also in sorting semicolon.
13.
Yeah.
13 here?
It's okay. No?
Okay, let's run
Let's
it.
run.
Okay, it's working now. Ah, but
No.
it's not working correctly.
Okay, I see it's not working because of like
No.
some
No.
mathematical stuff.
How about trying to change plus I?
To what?
I plus change to plus I.
No, it's working same.
I plus plus to I plus plus.
Plus I.
Operations to the
Not
forward.
I first.
Yeah.
Yeah.
You mean like this?
Uh,
I don't think it works like this, but
See.
something.
So how is it working? Like look when it's working. Like
Okay, this one is okay, this one is okay, this one is
Wait,
got it, I got
it's
it.
giving
I
the
got it.
5 like
If minimum is greater than that shit, there is no. There shouldn't be
Ah, this
semicolon.
one.
Yeah.
This one,
No.
is it like this?
No.
Minimum.
No, that is true, I guess.
Okay, let's try first like this.
no, it's not.
It's not completely true.
Like
Complete.
this way.
Also,
No, like you need to close the
close, yeah.
like parentheses.
Also start.
Like it's open right now.
Oh, that which one?
Like if
9 by 9 minimum.
and after the greater than sign, you need to open like.
Yeah. Sorry.
Let me see also.
And also here.
Also in 9 by 9, the last semicolon. Not semicolon. Just colon, I guess. Just colon.
I think nothing here.
No, it will print wrong.
Yeah, it's not working.
No,
It's
it
not-
worked. It worked.
Yeah, now it's working. So I think
How about can you just add like two column?
as a column
That is,
here,
I want to see because
like this.
I just want to see.
It's
Okay.
It's better in there. So it's finding our medium number. If you say let's give minus 20 and let's change to 6 here. Let's run. Let's find our function. That's working. So okay,
Yeah.
thank you guys.
수고하셨어. 고생 많았어요.
It's so cold.
Yeah, let's go. Can I leave?